Hello students, this is a video to help with the function family tree project that was handed out in algebra. The basic idea of the project is to build a function family tree starting from one of the parent functions that we discussed in class and moving on to creating different changes to those functions based on whatever you'd like. There are a couple different types of transformations that you can use, and I'd like to list them now. And these are the four different transformations that you can use. You can use a horizontal translation, which is a change to the inside of the parent function, a vertical translation, which is an addition or subtraction to the outside of the parent function. The dilation is when you multiply by a number on the front of the parent function, and a reflection is when you multiply either the inside or the outside by a negative number. And here you can see I gave a couple of examples. Here's a horizontal translation, 1 unit left of the parent function quadratic. Here is a vertical translation, 1 unit up of the parent function absolute value. Here's a dilation of the parent function square root, and here is a reflection of the parent function, this is a reflection across the x-axis, of the parent function cubic. All of these different types of transformations should be represented in your function family tree. If you're not sure what needs to be on your project, you can go to the page that says Function Family Tree Checklist. It has quite a lot of things that you have to take care of, but all of those things are listed. Keep in mind that the child function A, child function B, and also spouse function A, spouse function B, those are the four functions that you need to determine your own transformations to, similar to what I just showed on the previous page. On this next page of the checklist, it describes the grandchildren. Now keep in mind the grandchildren functions are going to be the combination of the transformations that you made for the child and spouse. So as a brief example, let's say you had child function A and spouse function A, and they had two different transformations that looked like this. So we have child function A, which is a vertical dilation by a factor of 4. Spouse function A is a right horizontal translation by 4 units. Grandchild function A1 would be a combination of both of these functions. So that means grandchild function A1 would have the transformation for the child function, which is a dilation of 4, and the transformation for the spouse function, which is a horizontal translation 4 units to the right. So it would look like this. So you can see grandchild function A1 has the 4 from the dilation from child function A, and it has the x minus 4 from the translation for spouse function A. So it combines the function rules of child A and spouse A. Once you do that, you name the different transformations on the graph. Here was a popular question that I got via email. So if we were to continue using that same example, child function A would have the transformation that we said before. Looks like this. So you would write out the transformation by hand, dilation by a factor of 4. Then underneath you would write the function rule, otherwise known as the function or the equation. That's a dilation by a factor of 4. So that's for child function A. Then spouse function A would look very similar, except it would have the other transformation that we had. So you can see that spouse function A has a horizontal translation 4 units right, and it's the same function rule or the same equation that we had before. Now for grandchild function A1, it would have a combination of both of the transformations. So it would be written like this. So you can see that in grandchild function A1, we've described the transformation verbally, and then the second transformation verbally, and then we've put them both together into the function rule. Now for grandchild function A2, we know all of the transformations for grandchild function A1, which is a dilation by factor 4 and a horizontal translation 4 units right. It says in the directions that we're supposed to use the opposites of those transformations. So if I direct your attention back to the beginning, you should see where it says the new happy couples will each have 2 children of their own called grandchildren. You're combining the equations of their parents to graph the new functions for the first child. Then you're performing the opposite transformations on the second child. So the second child, aka grandchild function A2, is going to have the same transformations but opposite. So in other words, they're the same type of transformation, but they are the opposite direction. So let's take grandchild function A1 for example. It's a dilation by a factor of 4, and it's a horizontal translation 4 units right. If we were to make it the opposite, it would have a dilation by a factor of not 4, but 1/4. It would be a horizontal translation 4 units not to the right, but to the left. it would look like this. So you can see that we have grandchild function A2, which is a dilation by factor of not 4 but 1/4, and a horizontal translation 4 units to the left. Observe the changes. You can see that f of x is equal to 0.25 x plus 4, and looks like we're missing a to the third power. There it is. So you can see that we have the same exact parent function, which the grandchildren functions would have, but the transformations have been reversed, and you can see that 1/4 is equivalent to 0.25. Alright, if you're trying to determine what adopted child function A is supposed to look like, you can refer back to the directions. The adopted child function is supposed to be the same types of transformations as the previous grandchild, but it would be a different parent function. So that's listed here. We have the adopted child, and each of the transformations are the same as grandchild A1, but it should come from a different family, so a different parent function. Here's what it looks like. Here we have dilation by factor of 4, horizontal translation 4 units right. This is grandchild function A1. So the transformation 1 and transformation 2 for grandchild function A1 should look exactly the same as the adopted child function, dilation by factor of 4, and horizontal translation 4 units to the right. The only difference between the the function for grandchild function A1 and adopted child function A is that this is from a different family. So we don't need that third anymore. We just need absolute value. Notice that the dilation is still there. The horizontal translation 4 units right is still there, but it's a different parent function than grandchild function A1, which is a cubic function. Now continuing with this example, remember we had the child function A being a dilation by a factor of 4, and we also had spouse function A being a horizontal translation 4 units right. That means the other two functions, the child function B and the spouse function B, should be the other two types of transformations that we talked about. For example, child function B is a reflection across the y-axis. It could be any of the reflections. So recall that means we're taking a negative and placing it inside the parent function. Same parent function, but a different type of transformation. And then for spouse function B, we have not a horizontal but a vertical translation, which is 2 units up. That is an addition to the outside of the parent function. Same parent function, different type of transformation. I'll briefly give you a look at what grandchild functions B1 and B2 and also adopted child B look like here. Alright, recall that child function B was a reflection across the y-axis, and spouse function B was a vertical translation 2 units up. So grandchild function B1 is a combination of both of those two transformations, same parent function. Grandchild function B2 is the reverse of both of those, so instead of a y-axis reflection, it is an x-axis reflection. Instead of 2 units up, we're going 2 units down. And then the adopted child function B is a exact copy of the two different transformations, y-axis reflection and 2 units up vertical translation, but it is a different parent function. And in this case, we used square root. I also provided a brief overview of what the function is supposed to look like. It starts with a parent function, and this could be in the trunk of the tree or whatever you'd like. Then you're having child A and spouse A together. Those have 2 different transformations, and those have 3 different branches coming off of them: grandchild A1, grandchild A2, and adopted child A. Similarly, on the B side of the family, we have child B, spouse B, grandchildren B1 and B2, which are combinations and opposite combinations as in the grandchild B2 case, and also adopted child B, which is the same transformations as grandchild B1, but a different parent function. If you need any more information about how the project is scored, there is a rubric that is attached to the project. I'm not going to speak exactly to the rubric right now, but take a look at a couple of the different categories. One of the important categories is the family tree poster. I got a lot of questions about the poster from my students, and I can say that the family tree poster does not have to be a large poster board that you go out and spend a bunch of money on at Michael's or what have you. You can just use a piece of paper, a piece of computer paper, or loose leaf is just fine, and if you must, you can leave those papers in the packet and simply graph them in the packet and hand that in. If you do make a poster, please make sure that it contains all the information and that is creative and appealing to the eye. All that means is that the graphs are neat and clean and they don't have any erasures or anything that makes them not look great. Please also keep in mind that I'm grading you on whether you identify the transformations correctly using words, whether you write the function rules correctly using equations, and whether you graph the transformations correctly using your graphing calculator or whatever you'd like. So those are the three different aspects of representing a function. You're representing a function using words, you're representing a function using the equation, and you're representing a function using the graph. Alright, that's about it for this video on the function family tree project. If you have any questions, please feel free to email me about it. But otherwise, I wish you luck on this project. Good luck studying.